Hello, beautiful people, and welcome back to another episode of the Space Stories Read Aloud series. Today, we are reading Journey Through Our Solar System by Dr. May Jemison. So, without further ado, let's get started. The sun is our source of light and heat. This bright ball in the sky may not seem very big, but it's the largest object in our solar system. Because the sun is so large, it has a lot of gravity. All of the planets, dwarf planets, asteroids, comets, and dust that orbit the sun and all the space in between make up our solar system. The sun's gravity holds it all together. 8 planets revolve around the sun in oval-shaped paths. The 4 planets closest to the sun are called the rocky planets. They make up the inner solar system. These planets are relatively small compared to the sun and are made mostly of iron and rock. They include Mercury, Venus, Earth, and Mars. Earth's distance from the sun gives it just the right amount of heat and light to support life. The planets of the outer solar system include Jupiter, Saturn, Uranus, and Neptune. These planets are much larger than the rocky inner planets. They are made completely of gas and have no solid surfaces. Scientists call them gas giants. Dwarf planets are smaller than all the other planets. Pluto, once considered the 9th planet, is now called a dwarf planet. Ceres is a dwarf planet that orbits between Mars and Jupiter. Eris orbits beyond Neptune. Smaller objects also orbit the sun. Asteroids are chunks of metal and rock. Many are found in the asteroid belt, a ring of asteroids that lies between the orbits of Mars and Jupiter. Meteors are chunks of rock that enter Earth's atmosphere. Most meteors burn up as they travel through the atmosphere. When a meteor reaches Earth, it is called a meteorite. Comets are mostly made of frozen gas, rock, and dust. Their orbits are very elliptical, bringing them close to the sun and then far away. Short-period comets may start in the Kuiper belt, beyond Neptune. These comets take less than 200 years to orbit the sun. Long-period comets take up to 20 million years to orbit. They may start in the Oort cloud, as an area scientists believe exists in the outer reaches of our solar system. Thousands of years ago, astronomers around the world, from China to Egypt to South America, knew the stars and the paths of most planets. Most civilizations believed Earth was the center of this universe. But in 300 BC, Aristarchus of Samos wrote that Earth and the planets circle the sun, and the sun is a star like other stars. Few people accepted this until 1543 CE, when Nicholas Copernicus again proposed a sun-centered system. This idea is the basis of modern astronomy. Starting in the 1600s, scientists used telescopes to make closer observations. Before, the planets Mercury, Venus, Mars, Jupiter, and Saturn had been observed by eye. Comets were only seen when their orbits brought them close to the sun. Telescopes led to the discovery of Uranus, Neptune, Pluto, and many asteroids, comets, and moons. Today, telescopes may be small and handheld or part of large observatories on Earth, but telescopes have the best vision when they are in space. Launched by the National Aeronautics and Space Administration in 1990, the Hubble Space Telescope has helped scientists observe even more objects in our solar system and beyond. The HST orbits Earth. It does not have to look through the atmosphere, so it gets a much clearer view of outer space. The HST has shown scientists many amazing images, such as distant galaxies and the birth of stars. Observing an object up close is one of the best ways to learn more about it, but objects in space are too far away for scientists to visit. So engineers and scientists develop spacecrafts that can be launched into space to gather information. These probes send data back to Earth for scientists to study. Flyby probes travel past one or more space objects. Orbiting probes spend more time studying a single object as they orbit it. The goal of an atmospheric probe is to collect data as it drops through a planet's or moon's atmosphere. A lander lands on the surface of that planet or object. A rover is a wheeled probe that can explore the surface over a larger area. A probe carries a certain equipment depending on its mission. Probes get their energy from onboard solar panels, nuclear fuel cells, batteries, or chemical power sources. Special cameras take pictures using different types of light. Equipment measures gases in the air or helps collect soil. Tools can sense temperature or study magnetic fields. Probes send this data back to scientists using radio signals. Large antennas pick up these signals on Earth. Scientists use the gravity of one or more planets to help probes make their way to another planet. This is called gravity assist. As a probe nears a planet, the planet's gravity speeds up the probe. This slingshots the probe to its next destination. Planets have to be lined up just right for gravity assist to work. That's why there is often a small amount of time, or window, during which a probe can be launched from Earth. Chapter 3. The National Aeronautics and Space Administration named the earliest space probe mission to the Sun Pioneer. The word pioneer means a person who is the first to explore a new area. The Sun is the center of our solar system. Learning more about our star would help scientists learn more about the solar system as a whole. On December 16, 1965, Pioneer 6 was launched into orbit around the Sun. In the 3 following years, NASA sent up Pioneers 7, 8, and 9. Together, the 4 probes acted like weather stations around the Sun. This helps scientists understand and predict occurrences such as solar storms. The Pioneer probes were designed to last about 6 months. They ended up gathering information for NASA for more than 30 years. Ulysses gave scientists a new view of the Sun. It was the first probe to study the Sun's poles. Ulysses made 3 orbits around the Sun and gathered data for over 18 years. Genesis observed solar wind. Solar wind is made up of particles pushed out from the Sun. Genesis gathered samples and then returned to Earth, landing in the Utah desert. Scientists at the Johnson Space Center in Houston, Texas, are studying these particles. The Mariner 10 probe made a flyby of Mercury, the closest planet to the Sun. Its photographs revealed that our smallest planet is covered in craters and ridges, much like our moon. Messenger, an orbiter probe, entered a path around Mercury in 2011. Already, Messenger is transmitting new information. Images show evidence of volcanoes in Mercury's past. Messenger's goal is to map the entire planet and gather data on its surface, interior, and atmosphere. NASA made some interesting discoveries when the Mariner 2 probe flew by Venus. The probe measured hot surface temperatures of at least 797 degrees Fahrenheit and a thick, deadly atmosphere containing sulfur. Magellan mapped the planet using a special type of radar that could see through the clouds. Magellan gathered information about the atmosphere before it crashed on Venus's surface. Mariner 4 completed the first successful Mars mission. This flyby probe took the first pictures of another planet from space. Mariner 9 was the first spacecraft to orbit another planet. It helped scientists select landing sites for future missions. Vikings 1 and 2 were designed to land on Mars' surface. These probes found evidence that water had once flowed on the planet. This showed scientists that Mars may have had the conditions necessary for life long ago. By remote control, scientists drove the wheeled rover Sojourner over Mars' surface. Sojourner performed tests on rocks and measured temperature and wind. The twin rovers Spirit and Opportunity studied the planet's water and weather. From their data, scientists found even more evidence that Mars once had liquid water rather than just frozen water on the surface. Curiosity was launched in 2011. The size of a large car, it landed in the Gale crater on Mars in August 2012. First, Curiosity burned through Mars' atmosphere protected inside a capsule. A parachute then slowed down the probe. Rockets helped adjust its position over the surface. Then wire cables lowered the probe gently onto the surface. Curiosity has many instruments on board. It's fitted with 17 cameras. It will use a laser beam to break up pieces of rock. It will analyze the air. Its arm will scoop up soil and rock samples. The rover itself can do tests on these samples. The probe will look for the chemicals in the air and soil that show life may have existed there once. This mission will also help us think about how future exploration will be possible by more probes or by people. And those are all the probes. Chapter 4. Probes travel through space and headed for a specific destination. But just because it is called space doesn't mean it's empty. The probe's equipment measures magnetic fields, space dust, and other data as they tour the solar system. While Pioneers 6 to 9 headed toward the Sun, Pioneers 10 and 11 headed in the opposite direction. Both carry plaques with information about humans, in case they are ever found by living beings out in space. Pioneer 10 was the first spacecraft to fly beyond Mars and through the asteroid belt that lies between the orbits of Mars and Jupiter. As Pioneer 10 passed by Jupiter, it transmitted hundreds of images of the planet and its many moons. Pioneer 11 flew by Saturn and observed its rings and moons. After their missions were complete, both of the probes headed out of the solar system toward distant stars. They continued to collect and send back information as they traveled through space. The flyby probes Voyagers 1 and 2 took videos and recorded magnetic fields and atmospheric data of objects they passed. Voyager 1 discovered rings and new moons around Jupiter and Saturn. Voyager 2 continued on to Neptune and Uranus, where it found rings around both planets. On Uranus, it found a boiling ocean of water beneath the clouds. On Neptune, it observed an extremely windy atmosphere. Afterward, both probes continued out of the solar system. Sending probes to other planets has helped scientists learn more about our own planet as well. Some probes, such as Galileo, Near Shoemaker, Stardust, and Deep Impact, have used Earth as a gravity assist. While they flew by, they captured images of our own planet. These images give scientists a view of Earth from space. Before Galileo reached Jupiter, it gave us new views of Venus and Earth. It flew close to the asteroids Jasper and Ida and photographed Comet Shoemaker-Levy 9, crashing into Jupiter's atmosphere. Once in orbit, Galileo studied Jupiter and its moons. It observed the moon Io's active volcanoes. It detected liquid water under the moon Europa's surface. This gave scientists more of hope of possible life there. Galileo also released a probe through Jupiter's atmosphere to collect data. Cassini was the first spacecraft to orbit Saturn. One of its goals was to study Saturn's moons. Cassini carried an atmospheric probe, Huygens. Huygens was released into Titan's atmosphere and took pictures of the moon's muddy and rocky surface. Cassini's images also showed geysers erupting from Enceladus' surface. Scientists didn't expect this from a moon they thought was frozen and still. The farther scientists want to explore, the farther probes will have to travel. It often takes probes years to reach beyond the inner solar system. New Horizons, a mission to study Pluto and the icy comets of the Kuiper Belt, was launched in 2006. It won't arrive there until 2015. When it finally reaches its destination, it may provide information to help scientists discover the origin of the solar system's water. The Deep Space One mission tested new engines and navigation software. The tests done with Deep Space One proved that longer missions are possible. The International Cometary Explorer was the first spacecraft to fly past a comet. Following this, Stardust collected comet dust samples with a substance called aerogel. Aerogel is like glass but much lighter because it's mostly made of air. It trapped thousands of particles from Comet Wild 2. Probes allow scientists to go to places they cannot go themselves. Scientists have been studying the data and images from probes. This has led to a better understanding of our sun, planets, and all the objects of our solar neighborhood. These missions will also help us prepare to send humans to other planets. The more scientists study, the more they can plan for the future and for the missions we can achieve in space. And that is the end. So again, that was Journey Through Our Solar System by Dr. Jemison. So that concludes this week's episode. I really hope you guys enjoyed it. And as always, I will see you next week. Have a happy holidays and a Merry Christmas and stay safe. Bye!